Okay, so welcome back. Now, in this example, it looks like something a little complicated, but we should recognize some of these terms in here. So, first thing that I'm noting is that we showed earlier that the series n equals 1 to infinity of 1 over n times n plus 1, we saw that converges, n converges to 1. Okay? We also showed that the series n equals 1 to infinity of 1 half to the n minus 1 also converges to 2. So since these both are convergent series, we can use the algebraic properties to tackle this one. Okay? So first of all, we're going to use the sum rule, we're going to use the constant rule, and then we're going to change this a little bit because this one isn't quite the same as this one, but we can fix that by changing the index and changing the variable. So let's do this. So we're going to write this as what? Let's write it as the sum, and I'm going to pull the 3 out, right? So there's a constant 3 here, so I can pull that 3 out. So I'm going to write this as 3 times the summation of n equals 1 to infinity of 1 over n times n plus 1. Okay? Plus, now here, well, let's just do this for a second. So I've got the summation of n equals 1 to infinity of 1 over n to the n minus 2. Okay, now, so far so good. Now this here, so we know this one here converges to 1, right? So this is going to be 1. This one here, it's not quite this, right? We've got an n minus 1 here where we get an n minus 2. So I need to add 1 here. So if I add 1, so I need to have n minus 1. So again, if I think about this, okay, so if I have n minus 2, and I want to rewrite this as, let's say, n minus 1 minus 1, well, I can write n minus 1 as m, right? So if I want m equals 1 here, right? So m equals n minus 1. So that would be what? M equals I still get m equals 0. So that doesn't seem like it'll work. Because I need 1 here. So let's, oh wait a minute, hold on a second. This is not, this is 1, sorry, I wrote that wrong. It's not n, it's 2. Okay, so let's think about this differently. So I can't play with the index. So, because that'll change this to 0, I don't want to change that. So I want to leave this alone to 1. But let's look at this here. So let's rewrite this. So I can rewrite this as I can use the property of exponents here. So this is going to be what? This is going to be 1/2 to the n minus 1 times 1/2 to the minus 1, right? So I can replace this with this, right? Let's do that. So let's split this up. And write this as 1/2 to the negative 1 power times 1/2 to the n minus 1 power. Okay, good. Now look at this. I've got a constant here, right? So I could pull that constant out in front. So what I end up with, this is going to be 3 times 1 plus, and then this becomes 1/2 to the negative 1 power times the series n equals 1 to infinity of 1/2 to the n minus 1 power. So now this series here, we know, converges to 2. Oh, and by the way, what's the inverse? What's 1/2 to the negative 1 power? That's the same as 2, right? So this becomes 2. And so what do we know? This thing converges to what? 3 times 1 is 3, plus 2 times 2 is 4, which equals 7. And so we know now that this series converges to 7. And we're done. See you next time.